So welcome to Electronics 6 Lab. So you are watching Signal System lecture series. In today is the topic of discussing the some elementary continuous time signals. Okay. So we'll see some standard means continuous time signals. Okay. So we have unit impulse, unit ramp, unit parabolic. Likewise. So let us see how the signals, continuous time signals are described in terms of the standard signals. Okay. So first, that is the unit a sample sequence or unit impulse. Okay. So in this case, uh, that is denoted as del of t. Okay. So we know that the continuous time demand is denoted as t. Okay, function of t. So it is the del of t, and it is defined as del of t equal to 0 for t is uh, not equal to 0. Okay. So when t is not equal to 0, this function is equal to 0, and this is the it is, if we integrate between minus infinity plus infinity, it will be 1. Okay. So let us see the graphical representation of this signal. So you can see at 0 it has the infinite height. Okay. So at 0 it has the infinite height. At it is not equal to 0, it is 0 everywhere. You can see it is 0 everywhere. Okay. So at this is the n at equal to 0, the value is your infinity. Okay. So you can see these are the 0. Okay. This is 0. The left hand side also, this is a 0. Okay. So we have only values is defined at t equal to 0. Okay. So this is the the area is equal to 1. Here the area is equal to 1. Okay. So we have the infinite height at the origin. Okay. And 0 everywhere. Okay. Everywhere it is 0. And we have with this arrow that indicates the height. Okay. And we have the area equal to 1. Okay. So this is our unit sample sequence. Okay. Unit sample signal also. Okay. So let us see. Next one is a unit step signals. Okay. So unit step signal is denoted as U of t. So unit step signal is denoted as U of t. The U of t equal to 1 for t is greater than equal to 0, and for t is less than 0, the U of t value equal to 0. Okay. So let us see the diagram. So this is the case when U of t equal to 1 for t is greater than equal to 0. Okay, so this is value is 1. So U of 0 also, what is the U of 0? So U of 0 also the means U of 0 equal to 1. Okay, so U of 0 equal to 1. Similarly, U of 1 equal to 1. So U of 2, which is equal to 1. So these are the values of U of value t when t is greater than equal to 0, the value is at 1. Okay. Similarly, in t equal to less than 0, you can see the values, all values are 0. Okay. So this is the unit step signal. Okay. So it is the, if t is greater than equal to 0, the value is 1. If t is less than 0, it is 0. Okay. So next continuous time signal is the unit ramp signal. Okay. So unit ramp signal is noted as R of t. Okay. It is defined as R of t equal to means R of t equal to t for t is greater than equal to 0, and it is 0 for t is less than 0. Okay. So this is the graph or diagram of a unit ramp signal. Okay. So you can see here the slope is equal to 1. Okay. It is denoted as R of t. Okay. So it is the keep on increasing. So one this means uh, at t equal to 0, it is 0. At t equal to 1, it is 1. Okay. Similarly, at t equal to 2, okay. So it is 2. Okay. T equal to 3, it is 3, and likewise. Okay. So it is keep on this increasing. Okay. So this is the unit ramp signal. Okay. Here the slope equal to 1. Okay. So we have now parabolic signal. Okay. So this is the denoted as P of t. So P of t denoted as P of t. So it is t square by 2 for t is greater than equal to 0, and 0 for t is less than 0. So this is the unit parabolic signal. Okay. So you can see this is the graphical representation of this unit parabolic signals. Okay. So we have the uh, P, it is denoted as P of t. Okay. So this is the graphical representation of this parabolic signal. So you can see again, if t equal to 0, it will be 0. Is t equal to 1, it will be half. Okay, 0.5 likewise. Okay, at t equal to 2, it will be 2. Okay, so t equal to 2. So this is p of 2. So it will be 4 by 2. It will be 2. So likewise, so it is gives on this in this type of graph we will find. Okay, so here the area equal to 1. Okay, so this is the unit parabolic signal. Okay, so next some elementary continuous time signal is the unit signal signal. Okay, so unit signals. Okay, so it is, you can see it is denoted as this SG and T. So T, for T is greater than 0, it is 1. T equal to 0, it is 0, and T is less than 0, it is minus 1. Okay, so this is the representation of a unit signal. At T equal to 0, it is 0. Okay, if T is greater than 0, it is 1. Okay, similarly if T equal to T is less than 0, it is minus 1. Okay, so this is the signal function. Okay, so this can be represented as a function of U of T also. Okay, so U of T also, so it will be, you can see this signal function which is expressed is the U of T. Okay, so it will be 2 ut minus alpha. Okay, so this can be expressed in the as a terms of U of T. Okay, let us see the last type of elementary signals, continuous time signal is the rectangular pulse. Okay, so rectangular pulse that we have, it is defined as x of t. Okay, and it is a rect of t by t. So where what is a? A is the amplitude of the pulse and t is the time period of the pulse. Okay, so let us see how the diagram looks like. So this is the rectangular pulse. Here the period is it will be t. Okay, so t by minus t by 2 to t by 2. So this is the amplitude a. Okay, suppose you have to find out x of t, which is equal to suppose 5 means rate of t by so suppose 2t by t. Okay, so you have to means represent this in terms of graph. So what will be the we have the amplitude that is 5. Okay, this is our a. Okay, so that can be a. So it will be 5 rect t by, that will be t by 2. Okay, so t by 2. Okay, so now it will the amplitude equal to 5, and the time, what is the width of this pulse, it is t by 2. Okay, the width of the pulse is t by 2. Okay, so we can extend from minus t by 2 to, okay, minus t by 2 to t by sorry, t by 4 to t by 4. That will be our representation of this signal 5 rect 2t by t. Okay, so this is how you can represent the rectangular pulse. Okay, so you have seen some continuous time signal. Okay, so this is all helpful in describing our discrete time systems. Okay, so you have seen what is unit impulse, unit step, unit ramp. Okay, and then unit signal, then rectangular pulse. Okay, so this is the some standard continuous time signals. Okay, so thank you for watching this video. Okay, so if you have any doubt, please free to ask me in the comment section. Okay, thank you all.